Hey, this is Coach Latham, your SOL coach, and today we're going to talk about functions in under 15 minutes. A function is a special relationship in which no x value has more than one y value. No x has more than one answer or one corresponding y. X values can be thought of as questions. They're the input into your equation. And y values can be thought of as your answers. Now we have a special name for the x's. They're called the domain. Those are the numbers that you stick into the function. And the answers, or the y values, those are called the range. It's important to remember, the domain is the x and the range is the y. The domain is the x and the range is the y. We've got a couple of tables here. And what we want to try and do is figure out if these tables represent functions. We've got x values, y values there, x values, y values there. Again, the way that we did it is we want to make sure that no x has more than one y. So we look down the left-hand column, the x values, and we see that we say 1 more than once because 1 maps to 1 and 1 also maps to 2. That doesn't make any sense. That's like saying, what day of the week is it? Friday. What day of the week is it? Thursday. You should only have one answer for the same question. So this one is not a function. Over in the table on the right, we've got a 2, a 3, a 4, and a 5. They're all different x's. They each map to only one answer. And therefore, this is a function. Now, some of you may be wondering about this 3 over here. Now, both 2 and 3 map to 3, but that's not getting a different answer for the same question. That's getting the same answer for different questions, and that's perfectly legal. It could be like if I said, what day of the week is it? And you said Friday. And then I said, what's your favorite day of the week? And you said Friday. Well, that's perfectly fine. The only thing that makes it not a function is when you ask the same question and you get different answers. Hopefully that's cleared it up. Now we're going to talk about domain and range here for a second. We said that the domain is the x and the range is the y. So for this one right here, which is a function, the domain is just going to be the collection of the x values, which will be 2, 3, 4, and 5. And the range is going to be the collection of the y values. And we creatively use a D for domain and an R for range. The y values are 3, 3. I'm only going to write that once, 5, and 9. So it's 3, 5, and 9. So that's how we name the domain and the range. All right, here's the same type of problem, only written a little different. We want to determine which one is a function. We look at our x's, 3, 4, 6, 6. No, because we got 6 twice. 6 is giving us 2 different answers, so not a function. We take a look at the next one. No parenthesis there. 3, 3, no. You can't have 3 as an x twice. They give us 2 different answers, so not a function. Take a look at the last one. 3, 4, 5, 6. All is good. We don't have any x's repeated, which means they all have only one y answer. So this one is a function. And then we'll do the same thing. We're going to write the domain and the range. The domain is the x values, which is going to be 3, 4, 5, and 6. 3, 4, 5, and 6. And the range is going to be the y values, which is going to be 2, 7, we're not going to write 7 twice, and 9. So 2, 7, and 9. There you go. That's how you find the domain and the range if you have ordered pairs. We need to do the same thing, tell if it's a function, and give the domain and the range if you get it in the graph form. Now, we're going to try and figure out which one of these are functions, and there's a nifty method for doing that called the vertical line test. If I draw a vertical line through every point in this function, I don't ever hit it more than once. So by that rule, this is a function. The same thing is true for this curve over here in B. I can draw as many vertical lines as I want to, but I'll never hit that red curve more than once. So this too is a function. If we take a look at this one on the bottom left, I've got a problem. If I draw a vertical line right there, I hit it twice. So not a function. And in this ellipse over here on the bottom right, there are lots of vertical lines I could draw that would hit it twice. So that one is not a function. If you draw a vertical line and you hit it more than once, then it's not a function. Let's take a close look at C just for a second, just to try and tie it all together with what we already know. This point right here has coordinates of -1, 0. This point right here has coordinates of -1, 3. So we got -1 going to 3, -1 going to 0 by the same rule that we talked about on the last two slides. That's not a function. We can give the domain and the range of functions that we find in graphs. Again, the important thing to do is remember the domain is the x. So we're looking for the x coordinates of these numbers. This one has an x coordinate of -4. This one has an x coordinate of -3. This one has an x coordinate of 0. And this one has an x coordinate of 3. So that's the domain of that. The range is going to be their y coordinates. This one has a y coordinate of -1. This one has a y coordinate of 1. This one has a y coordinate of 4. And finally, this one has a y coordinate of 5. So that's the domain and the range. Now, if you look straight up and down, what you get are the ordered pairs of each of those points. Like this point right here has the coordinates of -4, -1. We'll do the same thing with the graph at the right, only this time we have a continuous function, so we're going to have to write our answer a little bit differently, reminding ourselves that the domain is the x and the range is the y. We're going to look at what the x is on this curve. All right, so this is one end of the x, and this is the other end of the x. All right, so the lowest end of the x is right here at -5, and the highest end of the x is right over here at 5. And that function flows in between -5 and +5. So I'm going to put a little x in between my -5 and my +5. I've got a solid dot right here, which means that -5 is part of that function. So I'm going to put a less than or equal to right there because of the solid dot. And I'm going to put just a less than here because I got an open dot right here. So that is the domain of the function. The x values for this curve go between -5 and 5, including -5, which is why I got that equal sign right there. We're going to do the range the exact same way, only now instead of talking about how far over it goes, we're going to talk about how far up and down it goes because that's what y is. And remember, the range is the y. The bottom end of this curve with respect to y is right here at -4. The top end of this curve with respect to y is up here at 3. I'm going to put my y in the middle, and now I got to figure out where I have my solid dots or open dots. I got a solid dot up here on the top, so that's going to make this less than or equal to, and I got an open dot down here at the -4, so I just put a less than in. The other thing that you need to know about the domain and the range or about functions, I should say, is how to evaluate them or find f of some value. You got a lot of problems like this on your SOL test. It really is just an evaluation problem. They say, here's your function, find f of 2. What that means is you're going to put 2 in place of x and see what your answer is. So for this one, it's going to be 5 times 2 squared plus 2. Well, following your order of operations, you're going to square the 2 first. 2 squared is 4. So it's 5 times 4 plus 2. Then we multiply before we add or subtract. 5 times 4 is 20. And 20 plus 2 is 22. So f of 2 is equal to 22. When we put 2 in place of x, we get 22 for the answer. We'll do the same thing for f of 1. All right, our original function was f of x. Well, we'll call it f of negative 1 is equal to 5 times negative 1 squared plus 2. Going ahead and working that out, we've got to square first. Negative 1 times negative 1 is positive 1. So it's 5 times 1 plus 2. You multiply before you add. 5 times 1 is 5. 5 plus 2 is 7. So f of negative 1 is equal to 7. So what we're saying is, if you plug a negative 1 in place of the x, you get 7 for an answer. And if you plug a 2 in place of the x, you get 22 for an answer. Now those ones you plug in are your x's, and the ones that you get for your answers are your y's. So we can also think of them as domain and range. What this problem is asking you is it says, hey, what are the 3 answers? There may be individual answers, they could overlap, but what are the answers when I put 0, 1, and 2 in here? So this is really 3 problems in one. They're asking you to find f of 0, which is going to be 3 times 0 plus 2. They're asking you to find f of 1, which is 3 times 1 plus 2. And they're asking you to find f of 2, which is 3 times 2 plus 2. You figure out what your 3 answers are, and you know what your range is. 3 times 0 is 0. 0 plus 2 makes 2. 3 times 1 is 3, and 3 plus 2 makes 5. 3 times 2 is 6, and 6 plus 2 makes 8. So the domain is 0, 1, and 2. Those are the numbers that we put in the equation. And the range is going to be 2, 5, and 8. Those are the answers that we got out of the equation. This is everything that you should need to know for your SOL test, or at least everything that we could cover in under 15 minutes. Make sure to see your teacher for some practice SOL problems. Thank you.